might not like, some are scary too. As much as I love it, I just had to.
Hello everyone, myself Harshika Goyal. My roll number is 21EC30024. I am from ECE department. I am the group leader and I also contributed to the coding part.
Myself Bhavya Charitha, roll number 21 IM 10012 from the Department of Industrial and Systems Engineering. My contribution to this project is presentation and team coordination.
Myself Himanshoo Thakre, roll number 21MI10049 from the Department of Mining Engineering. My contribution to this project is coding and videography.
Myself Aditya G Gaikwad, roll number 21 EC30004 from the ECE department. My contribution to this project is hardware assembly.
Why gesture control card? Gesture control is the ability to recognize and interpret movements of the human body in order to interact with and control a computer system without direct physical contact. In this project, we use this technology to control a car using hand gestures. We aim to use this technology so as to replace the old button system with wireless communication. A simple hand gesture may be safer, quicker, and more convenient means to accomplish a task. Thanks to its size, gesture control car is portable so you can take it everywhere. Wireless control robots have many applications like remote surveillance, military, in wheelchairs, and in development of industrial grade robotic arms.
Now let us take a look at the receiver circuit. In the receiver circuit, there is the other part of the RF pair, a mini breadboard, an L293D motor shield, and an Arduino Uno. Now we connect the L293D motor shield on the Arduino. Then this is used to connect the battery to the L293D motor shield, and then with the help of this we give power to the Arduino. Let us take a closer look at the connections. In the motor shields, there are 4 terminals, the M1, M2, M3 and M4 for the 4 BO motors. The positive of BO motor is connected to the positive of M1 and negative of BO motor to negative of M2 and so on. Next, for connecting the RF pair to the Arduino, we do it directly from the motor shield. As you can see, we have soldered a wire for 11. This is for giving data from the RF pair to the Arduino. Then here we have soldered 2 wires, one at ground and one at 5 volt. So that is to give power and grounding to the RF pair module. Let us take a look at the transmitter circuit. In the transmitter circuit, we have used an Arduino Uno, an accelerometer, a mini breadboard, and one part of the RF pair module. This is the part which helps us transmit the data from our hand, that is this Arduino, to the car. Then this is the accelerometer which helps us detect the gestures of our hand, that if we tilt our hand forward, backward, rightward or leftward. Then the connections are made as follows. You can see the color of these wires and get to know the connections.
Now, we'll explain the code for ADXL sensor. First of all, we have defined two sets of variables, that is XYZ val and XYZ val2. Here, the difference would be calculated, and if the difference is greater than 40 units in the positive X direction, then the car will move towards the right direction. In the similar way, if the difference is greater than 40 units in the negative X direction, the car will move towards left. Similarly, if the distance is greater than 40 units in the Y direction, it moves in forward. And if it is greater than 40 units in negative y-axis direction, the car will move backwards. Now, let's go through the code for transmitter circuit. Here, we included the virtual wire library for RF pair module. Rest of the variables are same as in the previous code. For forward direction, F would be transmitted to the receiver circuit. For backward direction, B would be transmitted. For the right direction, R would be transmitted to the circuit, and for left direction, L would be transmitted. Now, we'll explain the code for receiver circuit. First of all, we have included two libraries. First is virtual wire, that is for RF pair module, and the second is AF motor, which is for motor drive. Here, we have explained four functions for motors. Now, in order to move forward, all the motors should be rotated clockwise. Similarly, for backward motion, all the motors are rotated anti-clockwise. For motion in right direction, motors involved in right hand side would rotate anti-clockwise, and that in the left hand side would rotate clockwise. This is vice versa for motion in left direction.